Okay, in this video we are going to start looking at surface area and volume of pyramids and cones. To start with, we're going to look at a little bit of vocab that's important for this and one example in this short video. So first thing is vocab. When we're looking at, you've seen some of this before with the previous volume and surface area sections you've done, but just to kind of review, we're going to match these and label them on this diagram down here. So when we talk about the slant height is going to be the height, hopefully that makes sense, the height of each lateral face. So this is going to be F. So down here on this diagram, the slant height, the lateral faces are everything except the base. Okay? So the base of this pyramid over here is going to be the square on the bottom, or the rectangle, depending on what it is. And then the slant height is going to be the height of those triangles around the outside. So in this diagram, this is going to be the slant height. Okay, so the height of the triangles around the outside. And when we talk about these pyramids, we're going to generally kind of talk about regular pyramids most of the time. And a regular pyramid is a pyramid with a base that is a regular polygon, meaning all of the sides of that base are going to be congruent and its faces are congruent isosceles triangles. Okay, so that's typically what we are going to deal with in this. So we're going to call this a regular pyramid. We're going to say that base is a square. Okay, and then a lateral edge is going to be option B. This is where two lateral faces intersect. So a lateral edge in our diagram, I'll use red here to kind of show here. So in this case, this thing's pointing to this segment right here. And that is where two of those triangles meet. So this is going to be a lateral edge. Okay. And then a base edge, back up here. A base edge is going to be where a lateral face and the base intersect. So that is going to be option C. So in our diagram down here, let's see, we have where a triangle and the base intersect each other where they meet. I'll use green here. We'll call this a base edge. Okay, and then an altitude is option D. This is the segment from the vertex perpendicular to the base. So a lot of times you'll see it called the height of the pyramid is the altitude. So in our diagram over here, I'm kind of running out of colors here, but we'll say that this going straight down the center of that pyramid right here, this is going to be the altitude. And then lastly, the vertex is going to be the option we have left is option A. And the vertex is going to be just basically the point where all the lateral faces of that pyramid intersect. So up top here where all of those triangles meet, this is the vertex of that pyramid. Okay? And then the only other thing that we have here is the base. The only thing we haven't labeled here is the base of this pyramid. So we're going to call this the base, basically what it's sitting on the bottom, the shape that's not the triangle. Okay? And let's see, the base is going to be this square down here. Okay, so that's going to be the base of that pyramid. And with these pyramids, we're going to start with finding what's called the lateral area. And the lateral area is, if you kind of look at this guy over here on the left, would be a pentagonal pyramid because the base is a pentagon, has 5 sides. And if you kind of unfold it, if you unattach it at the vertex and unfold it, you get this net. And you can kind of see that in this net we have 5 congruent triangles around the outside of it. Okay, and if we add up the area of all of those triangles, that is going to give me the lateral area. Okay, so what we're going to do is to find the lateral areas, we're basically going to find the area of one of these triangles, and we're going to multiply it by how many there are. Okay, so to find the lateral area, I give you the definition in a formula. So the formula is L equals 1/2 1/2 P times L, where in this P is the perimeter of the base, and L is the slant height. Okay, so we're going to take 1/2, and this uppercase L stands for lateral area. Sorry. Okay, so uppercase L stands for lateral area, lowercase l stands for the slant height. So we're going to take 1/2 of the perimeter of the base times the slant height. So we'll use slant height is the pink highlighter, and the perimeter of the base is the yellow highlighter. Just so you guys have a reference here. Okay, so this first example, we were asked down here to find the lateral area of this pyramid. Okay, so to find the lateral area of the pyramid, if we have our formula, 1/2 of the perimeter of the base times the slant height. If we want to find the perimeter of the base, if we check out this pyramid, the base of this pyramid is a square. Okay, so if we want to find the perimeter of the base, let's use this. We're going to take this 4, right? And you can either, since there are 4 sides, you can take 4 plus 4 plus 4 plus 4, right? Add 4 times for all 4 sides, or we could just take 4 times 4 and get that the perimeter of that base is 16. Okay, so we already have one thing we can plug into our formula. The other piece we need to know is we need to know the slant height, which if we check, the slant height is going to be the height of those triangles, right? So we are given that slant height over here. So L, right? And we said we're going to use the pink highlighter for L, for the slant height, and the yellow one for the perimeter of the base. Okay? So now that we know those two, we can plug them into our formula. So the lateral area is going to equal 1/2 of P, which again we said P was 16, and times L, which we said was given to us as 6. Okay, and if you multiply that out, 1/2 of 16 is 8. 8 times 6 is 48. And again, since we are talking about area, we're going to have inches squared. Okay, we are going to continue from the previous one where we found the lateral area of a pyramid. And in this one, we're going to take it a step further, and we're going to find what's called the surface area of a pyramid. And the surface area is kind of close to the lateral area. It involves finding the lateral area, but the surface area is the sum of the lateral faces and the base of the pyramid. So in this case, this is the surface area. Okay, so the surface area of a pyramid is going to use the formula surface area equals 1/2 of the perimeter of the base times the slant height plus the area of the base. So in this is going to stand for the area of the base. And then this S is going to stand for surface area instead of lateral area. Remember, those are two different things. Okay. And then we have seen this before. This 1/2 of the perimeter of the base times the slant height. So actually, this, where we have seen this before, this is just the lateral area. Okay, so that 1/2 of the perimeter of the base times the slant height is the lateral area. So literally all we are doing is we are finding the lateral area, and then we are adding in the area of the base. Okay, so we're adding one more step to this. So in these first few examples, we're given two different things. Okay, we're going to find the surface area of these pyramids, but in the first example, we are given an altitude of the pyramid. Okay, and remember, according to our formula, we have to know the slant height. Excuse me. So if we check, slant height is right here, which we don't know. So we have to be able to figure out how to find that. And in order to do that, we're going to look at the triangle that is created by the slant height and the altitude. So we are going to look at this right triangle in here. And if we check, we know the altitude is 16, so we know one leg. And if we look at this smaller leg, this point right here, according to the definition of an altitude, is dropped at the midpoint of the base. So that means that this point is cutting the base in half. So since it's cutting the base in half, we know that this has to be 6 centimeters. Okay, and now that we have both legs of that right triangle, we can use the Pythagorean theorem to find the slant height. So since we need L, we're going to use the Pythagorean theorem to find it. Okay, so we're going to set up a squared plus b squared. So 16 squared plus 6 squared is going to equal our slant height squared. And when you add those, square them and add them, you get 292 equals L squared. Take the square root of both sides to solve for L. And we're going to get L is about, it's not a perfect square, so it's going to be about 17.1 centimeters. Okay, so what we can do now that we have L is we can use this formula and we can figure out what's going on and we can find the surface area. Okay, so the other aspects we have L, we need to find the perimeter of the base. So if we check, the base down here is another square. So the perimeter of that base is going to be 12 times 4, right? Because we have 4 sides of 12. So the perimeter of that base is going to be 48. And then the other aspect we need is we need to know, we have the perimeter, we have the slant height, we have to know what the area of the base is. So to find the area of the base, since this is a square, to find the area, you take length times width, or side times side, whatever you want to do. So area of the base is going to be 12 times 12 since it is a square. So the area of that base is going to be 144 centimeters squared. Okay, so now we have P, we have L, we have B. So we have everything we need for that formula. So 1/2 of the perimeter, which was 48, times the slant height, which we found to be 17.1, plus B, area of the base was 144. So big thing is make sure you follow your order of operations here. When you're doing this, you can type it in a calculator, and you should get that the surface area is 554.4 square centimeters. Okay, so when you're given the altitude, it's a little bit extra work. Okay, and remember, like I said, this is how we found the lateral area, and this was the area of the base. Okay. Moving on to example B, if we're given the slant height, it's a little bit easier to work with, okay? Because we don't have to do all of this Pythagorean theorem stuff to find the slant height because we already know it. So in this case, if again, using our formula, perimeter of the base times the slant height plus the area of the base, then if we check perimeter of the base, again, if we look at this pyramid, the base is a square. Now, the base doesn't always have to be a square, but that's just what we're dealing with here. So the perimeter of the base is, again, we're going to take the length of a side times the number of sides. So the perimeter of the base is going to be 40. We already know, in this case, this is L. And then to find the area of the base, B, we need to take side times side. So since it's a square, the area of that base is going to be 100 centimeters. Okay, so to plug that in your formula, 1/2 of the perimeter, found to be 40, times the slant height is 13, plus area of the base, we found to be 100. So the surface area, if you type that in your calculator, should come out to be 360 square meters. Okay, and again, remember, all we did to find that surface area was this is the lateral area, and this is the area of the base. Okay, so all you're doing is finding the lateral area and then adding on the area of the base. Okay, so that is surface area of a pyramid. And then we are also going to check out the surface area of a cone and the lateral area of a cone in this video as well. Okay, so down here, if we check the formulas for lateral area and surface area of a cone, they're going to be kind of related to pyramids as well. So in this case, the lateral area of a cone is going to be, again, capital L stands for the lateral area. So lateral area is going to be pi times r, which you can imagine. R stands for the radius, times L, which lowercase l is still, just like it has been in the past, the slant height. Okay? So the lateral area is going to be pi times the radius times the slant height. And then just like it was with a pyramid, to find the surface area, we are going to take, hopefully that looks familiar, right? That's the same formula for lateral area. So we're going to take the lateral area plus the area of the base, which in a cone, the area of a base is always a circle. So it's the same, pretty much the same formula. You're still taking the lateral area plus the area of the base, just like we did with a pyramid. It's just the shapes are a little different. And again, this capital S stands for surface area, just like it did for the pyramid. Okay? So in these examples, though, we are asked to find the lateral area and the surface area, and it says leave your answers in terms of pi. So to leave your answers in terms of pi, that just means that we need to leave pi in our answer. We're not going to multiply it out. Okay? So in this case, again, we have two examples here. First one, we're given the altitude. So again, if we look at our lateral area and surface area formulas, pi times r times L. We need to know the radius, which we know a radius, and we need to know the slant height. But the slant height would be this. Okay? So this would be the slant height. This is an altitude. So just like we did with the pyramid, we are going to have to use the Pythagorean theorem to find the slant height. So luckily we know two sides here. So we can say 6 squared plus 7 squared is equal to L squared. And when you square those and add them, you get 85 equals L squared. Take your square root of both sides to find L. And again, not a perfect square here, so it's going to be right about 9.2 inches when you round it. Okay? So we now have the slant height. We have a radius, which we were given, right? So given the radius, so we can actually find the lateral area now. So if we plug these in, pi times the radius is 6 times the slant height 9.2. And if we multiply that out, again, we're leaving it in terms of pi here. So we take 6 times 9.2, and that is 55.2. And then we're going to leave pi right there. We're not going to multiply it out. And we are in square inches. So the lateral area in terms of pi is going to be 55.2 square inches. Okay? And we're also supposed to find the surface area. So to find the surface area, we're going to use this formula, pi r L plus pi r squared. And remember this, pi r L. We just found that because this is the lateral area, right? We just found that. So this is what we need right here for that part. And then this, the pi r squared, is the area of that base, that circle. So all we have to actually find is this. Okay? So if we want to take and find the surface area, pi r L, we already know up here is that 55.2 pi. And then plus pi times, we know the radius was 6 squared. So the surface area is going to equal 55.2 pi plus 6 squared is 36, so 36 pi. And to add these together, you treat these pi's just like x's. So we're going to add 55.2 plus 36, and we're going to get that the surface area is going to be 91.2 pi square inches. Okay, so that is how we're going to do it when we are given altitude instead of the slant height. Okay, and then last example here in this video is we're given the slant height. So same deal, right? Got to find the lateral area first. So we need to know the slant height, which we know. And we also need to know a radius. But in this case, we are given the diameter. So remember that the diameter is 2 times the radius, or the radius is half of the diameter. So this tells me that R should be 14.8 divided by 2, which is 7.4. So we already have everything we need in order to find the lateral area. So lateral area is going to be pi times radius we found to be 7.4 times the slant height is 15. And if we multiply that all out, we get 111 pi square centimeters. Okay, so that one's a little bit quicker and easier because we pretty much have everything we need right off the bat. And for the surface area, again, we have pi r L plus pi r squared for our formula. And again, we have already found this part. This is the lateral area, which we just found up here. Okay, so we have already found that part. So all we need to do is plug in the radius into that pi r squared, and we'll be good to go. Okay, so for your surface area, again, we already found this, which was 111 pi. And then if we add in plus pi times the radius squared, so radius we found to be 7.4, we square it, we get that the surface area is equal to 111 pi plus 7.4 squared is 54.76 pi. And again, if we just add these two together, 111 plus 54.76 is going to give me 165.76 pi square centimeters. Okay, so that kind of wraps up surface area of pyramids and cones, and next we'll take a look at volume. Okay, continuing on, we have already talked about surface area and lateral area of pyramids and cones. We're going to now shift gears and talk about the volume of cones and pyramids. So first examples down here, example 4, we're talking about volume of a pyramid, or volume of a cone, sorry. And in this, to find the volume of a cone, we have our formulas up here. So volume of a cone is going to be 1/3 of big B, which big B stands for area of the base, just like it did in your surface area formulas. Okay, so this is area of the base. Okay, and then the H is the height. Okay, and you notice in here that H is the height, it is not the slant height. Okay, so in this case we are talking about an altitude, not the slant height. Okay, so if we look at these first examples, well, and if we, before we do that, if we talk about the area of the base, in a cone, the area of the base is always a circle. So in this case, the area of that base is always going to be pi r squared. So we know that right off the bat. So in order to find the volume of a cone, we have to know the radius and we have to know the height. Those are the only two things we need to know. Okay. So if we check this out and we look at this first example, we're given an altitude in this first one. So we are actually given the height of this cone. Okay. So this is going to be our H, and we also need the radius, which we are also given. So this is going to be the radius. So in our formula, the volume equals 1/3 of pi r squared H. If we plug in everything we know the radius is 3.2 squared, and we know the height is 5.8. So I know the directions say leave your answer in terms of pi, but we're going to go ahead and round it because these are going to get kind of messy. Okay, so we're going to simplify this a bit before we go ahead and round it though. So if you take 1/3 pi and we take 3.2 squared times 5.8, we get 59.392. Okay? And then if you wanted to leave your answer in terms of pi, all we would have to do is take this and multiply it straight across. So the volume in terms of pi would be 59.392 pi over 3. And since we're talking about volume, we are talking about cubic units, so units to the third power. So in terms of pi, this is what our volume would be. And like I said, that's kind of messy. So we're going to go ahead and round it just so you can kind of see a little bit better. So if we take this times pi and then divide it by 3, the volume is going to be approximately 62.2 cubic meters. Okay, so it's a little bit easier to kind of see what's going on there. So that's if we're given the altitude. If we are given a slant height, okay, we're going to have to attack it just like we did in previous examples with surface area and lateral area, right? So if we're given the slant height, in order to find the volume, we have to know the actual height, not the slant height. So we need h. So just like we did in those previous examples, if I drop this down, we have a right triangle where we know the hypotenuse and we know a leg of that right triangle. So we can use the Pythagorean theorem to find the height that we need. So if I set up the Pythagorean theorem plus h squared, that'll be our h, equals 26.8 squared. Then this would be 144 plus h squared. 26.8 squared is 718.24. And solve for h, we can subtract the 144. So h squared equals 574.24. Square root to solve for h. And the square root of that is 23.999 something or other, right? So rounded to the nearest tenth would be 24.0, which kind of is nice. Okay, so we have the height. So to find the volume now, we're going to plug in 1/3 pi, the radius squared, so 12 squared times the height, 24. This one's a little bit easier to do in terms of pi. So if we do 12 squared times 24 divided by 3, the volume is going to be 1152 pi cubic centimeters. Okay, and just so you can kind of get a glimpse of what that actual number is, since we are approximating, we're rounding here, this is going to be 1152 times pi is going to be 3,619.1 cubic centimeters. And we will finish up finding the volume of a pyramid. All right, so last example here. We just found the volume of a cone. Now we are going to find the volume of a pyramid. And if you look back at the top of this page, okay, we have the area formula, or sorry, the volume formula for a pyramid. And it should look kind of familiar because it's the same thing as a cone, right? It is the area of the base times the height. So this time, the base, it can be various shapes. It can be a square, it can be a rectangle, it can be a triangle, it can be a pentagon, whatever. Whereas in a cone, the area, the base is always a circle. So this is going to be a little bit more general of a formula because the area, the base shape can change. So area of the base times the height. And again, just like with the cone, this is the height, not the slant height. So this is the altitude of that pyramid, okay? So if we look down at these couple examples here, finding the volume of a rectangular pyramid, we're going to round to the nearest tenth here. So in this, again, volume is going to be 1/3 area of the base times the height. Okay, common mistake is do not forget the 1/3. Okay, so make sure we divide by 3, whatever we do here. Okay, so to find the area of the base, in this case, since it's a rectangular pyramid, our base down here at the bottom, we know is, like it says, since it's a rectangular pyramid, the base is a pyramid, or sorry, the base is a rectangle. So to find the area of a rectangle, we're going to take length times width. So 9.5 times 8. So the area of the base is going to be 76. Okay, and then we are given the height. So we have everything we need to find the volume here. So if we want to plug this stuff in, 1/3 of the area of the base we just found to be 76 times the height is 9. So if we multiply that out, 1/3 of 76 times 9 gives us 228 cubic centimeters. Okay, so again, remember, rectangular pyramid, area of a rectangle is length times width. Okay, but in example B, we're given a triangular pyramid. So we're going to use the same formula, 1/3 of the area of the base times the height, but since our base down here is a triangle, finding the area of the base is going to be a little bit different. Okay, so remember the area of a triangle is 1/2 of base times the height of that triangle. Okay, so in order to find the area of the base, we need to know the base of this triangle at the bottom is going to be the 15, so 1/2 of 15, and then the height of this, the height of the base, so the height of this triangle at the bottom is going to be 6. So the area of the base is going to be, when I multiply this out, is going to be 45. And then again, to find the volume, we need the area of the base and the height, which we found the area of the base, and we were given the height. So we can go ahead, plug everything in. Area of the base we found to be 45. The height we found to be 14. Okay, so when we multiply that all out, 1/3 times 45 times 14 gives me 210, and we're in feet, so cubic feet. And that wraps up this section. So go on to your homework and try them out.